Boyle's law is a fundamental physical and chemical law that explains the relationship between the pressure and volume of a gas. It was first proposed by the 17th century scientist Robert Boyle 1627-1691. This law states that at a constant temperature, the volume and pressure of a gas are inversely proportional. In other words, when the temperature of a gas is held constant, if the volume of the gas decreases, the pressure increases, and if the volume increases, the pressure decreases. This can be expressed mathematically as P times V constant, or PV/PV. Here, P represents the pressure of the gas, V represents its volume, and 1 and 2 represent the states before and after the change. Boyle's law was experimentally confirmed. Boyle placed a gas in a sealed glass tube and measured the change in volume by varying the weight of mercury placed above the gas. As a result, he confirmed that increasing pressure reduces the volume of a gas and decreasing pressure increases its volume. Through this experiment, Boyle proved that gases have the property of compressing or expanding depending on the pressure. This principle later became the basis of the ideal gas equation of state PV/nRT and became the foundation for explaining the properties of gases in chemistry and physics. Boyle's law can be easily observed in real life. For example, when using a bicycle pump, pressing the pump handle reduces the volume of the internal air, increasing the pressure and forcing air into the tire. Similarly, Boyle's law is also related to the phenomenon of lung volume decreasing as the depth increases during deep swimming or scuba diving due to the increased ambient pressure. Boyle's law is also utilized in the medical field. When supplying air to a patient's lungs through a ventilator, the relationship between pressure and volume can be controlled to ensure safe breathing. However, several conditions must be met for Boyle's law to be accurately established. First, the temperature of the gas must be constant, and second, the gas must satisfy the ideal gas condition. In reality, some errors may occur because real gases behave differently from ideal gases under certain conditions, such as high pressure or extremely low temperatures. Nevertheless, Boyle's law is a fundamental principle of gas physics, and a very useful tool for understanding and predicting the relationship between pressure and volume. In conclusion, Boyle's law quantitatively describes the behavior of gases by elucidating the principle that, at constant temperature, the pressure and volume of a gas are inversely proportional. This allows us to understand the compression and expansion of gases, and applies it to various scientific experiments and engineering applications. This law was later combined with Charles's law and Avogadro's law to form the ideal gas equation of state, and is considered a significant scientific discovery that forms the foundation of modern physical chemistry.